Imagine standing outside during a thunderstorm. The sky flashes white. The world goes silent for a split second. Then comes the boom. But what are you really seeing? Not just a spark. Not just a pretty flash in the clouds. You are looking at one of nature's most violent electrical events. A burst of energy so extreme it can rewrite the air around it. And the deeper scientists study lightning, the stranger it becomes. Over the next 10 facts, that familiar bolt will turn into something hotter, louder, rarer, and more mysterious than most people ever realize. Number 10. Lightning can be hotter than the sun's surface. A typical lightning channel can heat the surrounding air to about 30,000 Kelvin, or roughly 53,500 degrees Fahrenheit. The visible surface of the sun is around 5,500 degrees Celsius. That sounds impossible, but lightning is packed into a tiny channel, and lasts for only a tiny moment. The heat is intense, but brief. So brief. Still, that sudden heating makes the air expand explosively. And that is where thunder begins. The boom is not separate from the flash. It is the flash. Number 9. Thunder is literally the sound of lightning. When lightning tears through the air, it heats that air so fast that the air cannot stay in place. It expands in a violent rush, and that rush becomes a pressure wave. We hear that pressure wave as thunder. So every rumble in a storm is the sound of air being forced apart by electricity. That is why thunder can sound sharp, deep, rolling, or endless. It depends on distance, atmosphere, and the shape of the storm. And if the storm is close enough for you to hear thunder, it is close enough to matter. Stay alert. Number 8. You always see lightning before you hear it. That is not a trick of the storm. It is simple physics. Light travels much faster than sound. So the flash reaches your eyes long before the boom reaches your ears. Thunder moves through the atmosphere at roughly 343 meters per second under normal conditions. That delay can even help you estimate distance. Count the seconds between flash and thunder. And every 3 seconds is about 1 kilometer away. 15 seconds? That is roughly 5 kilometers. But here is the part that matters most. If you can hear thunder, you are close enough to be struck. When thunder roars, go indoors. Number 7. Lightning can strike the same place again and again. The old saying says it never does. That saying is wrong. Lightning often returns to tall, isolated targets, especially skyscrapers, towers, and other prominent structures. The Empire State Building is a famous example because it can be struck repeatedly during storms. In fact, some tall structures are hit every year. Why? Height matters, but it is not the only factor. Shape, electrical conditions, and the developing channel all help decide the path. Lightning is not random chaos. It is a search for the easiest route. And sometimes, that route goes upward. Number 6. Lightning can travel upward from the ground. Most people picture lightning falling from clouds to earth. But tall objects can send a charge upward too. Towers, skyscrapers, and mountain peaks can launch upward lightning when conditions are right. A charged object can send a leader rising toward the storm until it connects with the descending channel. That means the strike is not always a one-way fall from the sky. It can be a meeting point between the ground and the clouds. That is one reason tall structures are so vulnerable in thunderstorms. They do not just attract lightning. They can help build it. Number 5. One flash can contain multiple strikes. What looks like a single bolt may actually be several electrical discharges racing through nearly the same path in rapid succession. That is why lightning can seem to flicker or pulse. To your eyes, it looks like one clean burst. In reality, it can be a fast sequence of surges, each one carving through the same channel. The branching shapes are not decoration. They are the visible result of electrical breakdown in the atmosphere as the discharge searches for a route. Lightning is not one instant. It is a chain of decisions made in fractions of a second. Number 4. Lightning can injure people even when it does not hit them directly. When a strike reaches the ground, the current does not always stop there. It can spread outward through the surface. That is called ground current. It is one of the reasons lightning is so dangerous at a distance. A strike several meters away can still send electricity through the earth. A person nearby can become part of that path. That is terrifying, because it means the storm does not need to strike right next to you to be a threat. If thunder is close, the danger is close. That warning matters every single time. Number 3. Lightning can reach far above thunderstorms. Scientists have discovered strange upper atmosphere flashes called transient luminous events. Some of the most dramatic are sprites. They can appear high above thunderclouds, stretching for many kilometers. And they often look red, branching, or jellyfish-like. There are also blue jets and gigantic jets that shoot upward from storms. For centuries, people had no idea these existed because they are brief, rare, and easy to miss from the ground. But they are real. And they show that lightning is not confined to the cloud tops. It can reach into a hidden electrical world above the storm. Number 2. Thunderstorms can produce gamma rays. Not just light, not just heat, but gamma ray flashes. These are called terrestrial gamma ray flashes, and they are associated with powerful storms. Scientists have even detected them with satellites orbiting Earth. Think about that. A storm below you can generate bursts of energy so intense they can be sensed from space. That changed the way researchers think about thunderstorms. They are not simply rain machines with occasional flashes. They are enormous electrical systems, capable of accelerating particles to extreme energies. Lightning is not only dramatic to watch. It is powerful enough to be studied from orbit. Number 1. Lightning can melt sand into glass. And it may have helped create the chemistry of life. When lightning hits sandy ground under the right conditions, the heat can fuse the sand into a glassy structure called a fulgurite. It can preserve the path of the strike like a frozen signature. But the story gets even bigger. Scientists have long wondered whether lightning also played a role in the early chemistry of Earth. In the famous Miller-Urey experiment, electrical sparks were used to mimic lightning. And the result was several organic compounds, including amino acids. That does not prove lightning created life. It does show that electrical energy can drive the chemistry that life depends on. So the next time you see a storm build on the horizon, remember what is really happening. A natural electrical system is heating air hotter than the sun's surface, creating thunder, striking the same place more than once, reaching upward from the ground, and even leaving traces in sand and space like flashes above the clouds. Lightning is beautiful. It is terrifying. And it is far more complex than a single bolt in the sky. Nature does not need special effects. It already has lightning. Comment the fact that shocked you most. And subscribe for more science.